Exploring faraway stars seems to be just science fiction, even with the fastest man-made probe, as it would take us 6.6 thousand years to reach our nearest star, just 4.2 light years away. The probe is expected to travel at just 0.064% the speed of light. Certainly. Also, general relativity states that there appears to be a universal speed limit as to which an object can travel, and that is the speed of light. Say we managed to send the probe as fast as light, it would reach the star in just 4.2 years. Cool, right? Actually, not so much. See, the issue is due to time dilation, time will pass slow on the probe, but on Earth, thousands of years would have been lapsed. So, even if the probe reaches the star, we won't hear back from it, as humans would have been long gone. So, what should we do? Our Earth can't sustain us for long. Even a bird has to leave its nest someday. We can move through space faster than light. But how about we move the space around us? And basically, that's how warp drives can achieve faster than light speeds. Alcubierre warp drives.
The most practical way we can achieve hyperspeed travel within general relativity. Now, all these equations are fairly advanced, so kids, don't try this at home. But don't stress, I'll help you understand the concept easily.
So, general relativity again tells us that we live in a world with more than just three dimensions, with time being the fourth dimension, and collectively calling the 3D space and time space-time. And where there is a limit as to which an object can travel, space-time can expand at any speed it wants and has been doing so since the Big Bang. Now that space-time can contract and expand faster than the speed of light, the warp drive expands the space behind it and compresses the space in front of it, keeping us in a uniform space. Think of it this way. Assume this paper spring as the uniform space between Earth and the star. The warp drive expands the space behind us using negative mass and compresses the space in front of us using superdense mass, effectively taking us from one point to another at hyperspeeds just by moving the space around us. To expand space, the negative mass we need is a funny thing involving the Casimir effect. To contract the spacetime, we need an oscillating toroid of superdense QD vacuum field. But why oscillating? Well, oscillating the toroid softens the spacetime, which is actually very stiff, and makes it easier to warp it. Also, it creates a stable bubble in which the craft can sit safely. And as the space inside the bubble is not warped, craft experiences time with the same speed as that on Earth. And that's how we can achieve hyperspeed travel. Pretty impressive, right? Well, always stay curious, my fellow Earthlings, and thanks for watching.